And you know about the introduction of chemistry. Chemistry means it's like getting new products and doing different research work and getting new things. Okay, moreover, before going for separation, we should know what are the pure substance and what are the impure substances. Okay, pure substances are nothing but homogeneous material which contains particles of only one kind and has a definite set of properties is called pure substances or elements. Understood? So what are the pure substances in general? Iron, silver, oxygen, like almost 118 elements what we are having, all are pure. Okay, if I take iron, a bar of iron, for example, if we consider this is a bar of iron, when I break a bar of iron into simpler pieces, I'll get only iron particles in it. Good. So example of the common salt is sodium chloride. If we consider sodium chloride consists of sodium and chlorine. Though it is of two different components present in it, both components together will give only one single property. That's why even compound is considered as pure. Understood? So we have already discussed pure pure substances are nothing but element and compound. Next. So if we have observed the mixtures, we have already discussed about the mixture. Mixture is nothing but it's a combination of two or more substances mixed together in any proportion, do not undergo any chemical change but retain the characteristic. This resulting mass is called the mixture. Okay. So when we have seen about the mixture, so mixture is nothing but it's like when you have seen the compounds. If we have taken any components together in a definite proportion, if I want to mix iron and sulfur, if I want to mix iron and sulfur, if I want to take a fruit salad, I'll break the fruits into different pieces and I'll add it. When I'm adding it, what we'll observe? We're just adding based on the taste or flavor, based on the things like I want to take more apples. So in that fruit salad, I'll take more apples. It doesn't require any proportions. But when we consider compounds, like H2O is a water, it consists of 2 atoms of hydrogen and 1 atom of oxygen. 2 atoms of hydrogen and 1 atom of oxygen. That is fixed. Though the availability of hydrogen is more in the atmosphere, it won't take hydrogen more. Why? Because they are fixed in proportion. If we take mixture doesn't require any proportion. If I want to prepare lemonade, what I'll do? I just take the water in a tumbler and I'll add lemon and I'll add flour, like to enhance the flavor, I'll add a bit of salt, a table salt and a sugar. When I mix it, based on the flavor I'll take. It depends upon the flavor. It doesn't mean that it needs a fixed measurements. So lemonade is considered as homogeneous mixture. So when we see that lemonade, we can't differentiate what are the things present in it. What are the compounds present in it. That's why it's considered as homogeneous mixture. Understood, children? So when you consider heterogeneous mixture, heterogeneous by seeing heterogeneous. Yes, Yashika.
Is air example of homogeneous mixture because it contains oxygen.
Yes, 100%.
Other gases.
100%. Other gases. So air is an example of homogeneous mixture because we can't differentiate different gases present in air. We know that different gases are present in the atmosphere or in the air, but it is homogeneous. We can't differentiate individually. So it is considered as homogeneous mixture.
From in the air, that is gas in gas, right?
Yes, dear.
In the air, gas in gas, right? In the air.
Yes. Okay, so if we consider heterogeneous mixture is a combination of mixture of sand or any other thing. So when we mix sand or water, when we allow to add sand in water, so after dissolving also we'll find the sand is saturated like sediment at the bottom, and we'll find a different layer of water present over. That means heterogeneous mixture is easily available. We can find the phases. Understood? Understood, children? We can find the phases about it. So this is about the mixture. Mixture are of two types. One is heterogeneous, one is homogeneous. Though it doesn't require any proportions, when we consider homogeneous mixture gives a single property. Single property in the sense single phase. We can't differentiate what are the components present over. When we consider heterogeneous mixture, it also doesn't require any proportions, but you can easily find different phases present in that particular mixture. Oil in water, sand is mixed with any other components, sand in water. Understood? Wheat flour with any other seeds, all this considered as heterogeneous mixture. So homogeneous mixture, the definition for the homogeneous mixture in which different constituents are mixed uniformly. This is known as homogeneous mixture. Here we have taken brass. The brass, we can find that homogeneous in nature, but the brass consists of copper, tin and everything in different proportion. But we can't find them by our visual effect or with our naked. But here also, milk of water, mixture of water and milk. When the water is added in milk, we can't find the water present over. We'll feel that it's just a milk without any adding of water.